So we're going to do a new method of solving systems of equations, of linear equations, and that's to use something called adding and subtracting. Now, I know that I can add and subtract anything from an equation provided I do the same thing to both sides. Like if I were to go ahead and subtract 3y from each side of this equation, I would be left with 2x is equal to negative 3y plus 11. So that's just rearranging things around. But what we're going to do is we're going to take that to a new level on the next slide. So here I now have a system of equations and I need to solve them. So this would be a little bit hard to do with substitution. It would be kind of hard to graph because they're not exactly with intercepts. So we have to come up with a new method. And so what we're going to do is we're going to go ahead and say, hey, you know what? This here is equal to this here. So it's sort of like subtracting the same thing from both sides, or adding the same thing to both sides. As long as I do the same thing to both sides, it doesn't matter. So what I'm going to do here is I'm going to go ahead and add the same thing to both sides of the equation. I just put that in parentheses and put an addition symbol down there to make sure that it's clear what I'm doing. And what's going to happen is I'm going to combine terms. 2x plus negative 2x is just going to be 0x. 3y plus 5y is going to be equal to 8y. And that's going to be equal to 13 and 11 together. That's going to be 24. So I'm left with 8y is equal to 24. And so y is going to be equal to 3. So I'm going to now go back up to one of the original equations, plug it in, and solve for x. So I'm going to do that yellow here. So 2x plus 3 times 3 is equal to 11. So 2x plus 9 is equal to 11. Subtract 9 from both sides. You end up with 2x is equal to 2. So divide both sides by 2, you get x is equal to 1. So my point should be 1, 3. And now I'm going to test that in the second equation here. I'm going to test this in the original second equation here. So it should be in green here, negative 2 times 1 plus 5 times 3 should be equal to 13. So negative 2 plus 15 is equal to 13. And that's true, so I know that this is true for both of the equations. And so that's the way of solving using using addition and subtraction instead of substitution or instead of graphing. So in this system of equations, I've got 3x minus y is equal to 30 and negative 3x plus 7y is equal to 6. So what I'm trying to do is I'm trying to figure out something that matches up here that can cancel out, and this over here is what cancels out if I add them together, 3x and minus 3x. So if I add them together, I'm going to remind myself that I'm going to add these. When I do that, I end up with a 0x here. Negative y plus 7y is going to give me 6y. 30 plus 6 is going to give me 36. So 6y is equal to 36, so y is just going to be equal to 6. So now I'm going to plug that into one of the equations up here. Plug it into this first one here. And y is equal to 6, so 3x minus 6 is equal to 30. I'm going to add 6 to both sides. 3x is equal to 36. So x is going to be equal to 12. So I'm going to divide both sides by 3. So I've got my point now. My point, I think, is going to be 12, 6. I've plugged it into the first equation. That's what I did here. Now I'm going to plug it into the second equation here. When I do that, if it's true, then I know I have the solution for both of them. So negative 3, x's value is now 12 that I'm testing, plus 7 times y's value is now 6 that I'm testing, is equal to 6. So negative 3 times 12 is going to be negative 36 plus 42. Is that equal to 6? Yes, it is. So this is the solution for both of them. So in this problem, we're actually not going to use addition, because if you look at this here, I don't have anything that matches up that would cancel each other out. What I do have here is I have y and y, but they're both positive. So instead of using addition, I'm going to use subtraction on all of this. What that means is I'm going to subtract what is x minus negative 2x. That's going to give me 3x. Y minus y is going to give me 0y. And 1 minus 4 is going to give me negative 3. So if 3x is equal to negative 3, then x is going to be equal to negative 1. Going to plug that into the original equation. So up here, I'm going to plug it into this one right here. It's going to be negative 1 plus y is equal to 1. Going to add 1 to both sides. We're just solving for y now. Y is going to be equal to 2. So my point, I believe, is going to be negative 1, 2. Now I've got to plug it into this second equation, the original second equation. So it's going to be negative 2 times negative 1 plus 2 is equal to 4. Negative 2 times negative 1 is going to give me 2 plus 2 is equal to 4. That's true. So it's true for both of the equations, so that means my answer is that. And really that's all about recognizing whether you need to add or subtract. In this case here you need to subtract because the terms don't match up, or they are the same term instead of having opposite terms like in the addition problems. So last example here. In this case here I have two equations, negative 8y plus 6x is equal to 36, and 6x minus y is equal to 15. And it doesn't exactly line up perfectly, so I have to rearrange them a little bit. So I'm going to rearrange the top one so it's in standard form. So it'll look just a little bit differently. I'm going to rearrange so the 6x comes first, and so then it'll be minus 8y is equal to 36. Not changing what it says, just rearranging it a little bit. Second one I'm going to leave in standard form. Now I have to determine, am I adding or subtracting to get rid of this x term? Well, they're the same sign, so I'm going to go ahead and subtract. When I subtract, I end up with 0x. Then negative 8y minus y is going to give me negative 7y is equal to 36 minus 15. That's going to be 21. So negative 7y is equal to 21. So y is going to be equal to negative 3. So now I'm going to plug that into the original equation here, one of the original equations. I'm going to choose this time to plug it into here. So it's going to be 6x minus negative 3 is equal to 15. 6x plus 3 is equal to 15. 6x, subtract 3 from both sides, is equal to 12. So x should be equal to 2. So I believe I've got my point. It's going to be 2, negative 3. So I think it's going to be. So now I just got to plug this 2, negative 3 into the other equation. So I'm going to plug it now into this one here and see if it's a solution for that one too. So negative 8 times negative 3 plus 6 times 2 is equal to 36. I'll write this over here. This would be 24 plus 12 is equal to 36. That's true, so I know that this is a solution for both. And we're done.